Okay, welcome to the section of campus fabric design with Juniper Mist Cloud. Really excited to introduce this. So today, this is Sujit here. Abhi and myself, we are going to tag team for this session. We're going to show you some couple of slides in the beginning to set the stage, and then we are going to jump into some demos on how we are designing this campus fabric network. Okay. So let's talk about why did we start this journey on campus fabric? What are we trying to solve over here? We are seeing lots of layer 2 devices connecting to the layer 3 networks, causing lots of issues over there. Over a period of last 20 years, we have seen proprietary technologies like MCLAG, etc., has been introduced to eliminate that spanning tree problem or STB loops problem. And also at the same time, these networks are not flexible or not scalable. When your networks are growing, how can you extend that VLAN to the other building without breaking your network? And obviously, mobility is key. IoT devices coming in is key onto this network. And all it's land up is increasing number of ACLs on any devices. Typically, we have seen customers adding ACLs and they don't remove them over a period of time because you don't know what's going to break. Whenever security is involved, we want to be really careful. So this has led to more configuration errors, having different configurations on different places, increasing the number of trouble tickets, and at the end, in our land, we always say reducing the device experience or the user experience on it. So that's the reason we started the journey of AI ops with campus fabric. So this is what we are introducing today. Very excited about it is Mist AI and cloud services now will be able to support EVPN-VXLAN fabric management. So now we will be able to go in, onboard the switches through the claim codes. Then we can do the fabric deployment on the basis of the architectures we want to do, cloud manage the fabric, as well as the AI operation, which Sunilni and Api talked about. And then most important thing is we are introducing the EVPN-VXLAN based on the standards version of EVPN-VXLAN, including group-based policies or GBP. So I'll walk you through along with Abhi for our next couple of minutes on all of this in detail. So now what we have is this complete fabric design from ground up. Once you get your switches delivered to you, you unbox them, they have a QR code on it. You will be able to scan that QR code, bring that switch online, go through the ZTP process and add them to the cloud. Once they're added to the cloud, then you can decide on what type of architecture you want to deploy. Is it an EVPN multihoming, a campus fabric distribution core, distribution network, or IP clause? And once you do that, then comes the day 2 operations, which we talked in detail in the earlier section with Sunilni and Abhi on troubleshooting and managing with the Marvis AI and the Mist AI. So that's the journey we are going to take. But I want to bring your attention to one more thing. When we initially talked about the platforms, when Sudhir talked about the platforms, we were talking all about the EX platforms, the EX 2300s, the 3400s, and the 4400s, to mention some of them. But today, we are really excited to introduce to you all the support for QFX platforms, which are relevant for campus deployments to be supported on Juniper Mist Cloud. So moving forward, the QFX 5110 and the QFX 5120 platforms will also be supported for the EVPN deployment or any kind of deployment on the Juniper Mist Cloud. That's something we are introducing new. Now let's talk about the campus architecture. This is very important to understand where we stand, what type of architectures we support on it. You can start small. You don't have to start your EVPN journey with the full campus. You can start small. We can support all of these architectures. You can start small, saying that I'm just having a building or 2 or 3 buildings and has 3 floors on it. about 5,000 users, anywhere between 2 to 5,000 users, I am going to start doing EVPN deployment, what we call as EVPN multi-homing at this particular site. And in this case, you can see I have a collapsed core of switches on the distribution, and I am enabling EVPN-VXLAN on that collapsed core network. Your switches at the bottom, the access switches at the bottom, they could be on a VC or could be a standalone, and they are on the layer 2 mode only. In this case, you have choices of using all these access switches, which we have starting with the 4400, going all the way to the 2300 platforms. Then comes the larger networks. We are talking about enterprise campuses. We are talking about say, any of the university campuses where you have a 3-layered network, where you have your distribution, core, and then you have your access. Now you can extend that EVPN-VXLAN between your core and distribution. Your access layer still remains as same, which is based on either on a virtual chassis or on a standalone, and you have deployed them as layer 2 mode only. We have 2 varieties under this. One of them is called CRB and the other is called ERB. CRB stands for centrally routed and bridged, where you have your layer 3 gateway on the core of the device itself. And that is recommended for a lot of north-south bound traffic. In a typical enterprise, for example, you have Zoo, Office 365, etc. going on. But if you have an environment in a campus, could be a university campus, where you have a lot of east-west traffic, then you can deploy this ERB architecture, where your layer 2, layer 3 gateway remains on your distribution switches. Because you are trying to communicate between different buildings in the network, that's when we recommend the core fabric distribution with ERB. So you have 2 options, CRB and ERB. Then finally, extending that EVPN-VXLAN all the way to your access layer. So in this case, you can use the 4400 switches or the 4300 MP switches to deploy and extend that EVPN-VXLAN to the access layer. At the same time, now you bring in this additional functionality on top of it with the 4400 switches is GBP or group-based policies. Because you might be asking, Sujit, why do I care about IP clause? With IP clause, you will now be able to talk about GBP. And I'll talk about that in detail in a couple of after we finish through this design portion of the campus fabric. But the most important message over here is you can start small. You can start small with EVPN multi-homing and grow in your network from the Juniper Mist platform. We have support for multiple architectures. And at the same time, you can have a single site which can have a EVPN multi-homing, or could be a campus fabric or campus fabric IP clause. And all of this is based on standards version of EVPN-VXLAN, including GBP on it. So now let's talk about how you're going to deploy this from the fabric. This is the 4-step process. First is, obviously, you need to decide what you're going to deploy. Are you going to do an EVPN multi-homing, campus fabric with IP clause, or campus fabric IP fabric distribution, core distribution? Once you decide on that, next comes the networks or the users you want to. You can say, I'm going to have a network for employee, I have a network for guests, and I have a network for IoT. You can map them to 3 different VLANs, and those VLANs can be mapped to 3 different VRFs. And you can take those VRFs all the way to your firewalls and let the firewall decide that if you want to talk between your employee network and your IoT network, guest is kept completely separate all the way to your firewall, do the translation and take it out. Guest traffic cannot go to your employee traffic or employee VLAN or VRF. or to your IoT. So that's where we define the networks and map them into their own swim lanes. Then comes the physical connections. That means now you're selecting the switches which are going to be acting as your core or a distribution or an access switch, and how you do the physical connectivity between them. And then finally, you apply the intent on it. That means your intent was to deploy a EVPN fabric network, EVPN multi-homing or IP clause. This is where we go in and do the necessary configurations and push that information all the way to the network. So behind the scenes, what happens? What happens behind the scenes? I showed you the 4-step process of what is going on or how you build up the EVPN network. Behind the scenes, we take a couple of steps. We deploy your underlay network using eBGP. Overlay network, which is required with your iBGP peering and also our route distinguishers and all those EVPN v4 addresses needed. Then we define the layer 2 gateway, where we do the VLAN to VXLAN mapping. We do the layer 3 gateway, also the IRB definitions, the VLAN information, as well as VXLAN to VLAN routing in this case. And then finally, we do the lag or link aggregation to the fabric. We use ESI lag from fabric to the access switches. So all of this is happening at the back end. So all you're going to do is provide some very basic information which is needed to configure all of this and push down to the switches in order to deploy your campus fabric. You don't have to bother about your underlay. Am I using BGP? What is going on with my BGP? We will be taking all of this away from you and telling you that give me basic information for underlay, give me basic information for overlay, and we will do the deployment. So this is what happens behind the scenes when you go through the provisioning.
Sujit, quick question for you. What
Sure.
if you did want to bother with that configuration and you wanted to see, what it was exactly what it was deploying from a configuration perspective? Is that possible?
Yes, we allow you to look at the configuration. There are several ways to look at the configuration. One is obviously you can use the API call, which is our primary, and some of those magic, Jake is going to show it to you. You can make an API call to see what configuration is constructed and pushed from the cloud to the switches, or before they are actually pushed to the switches, you can see those information. Or you can always download the exact configuration we are going to push from the cloud in a simple text file, and that will be available for you to look at to see what type of information is getting pushed out. So you have the options of looking into that operations, using the APIs, using the download Junos config feature if you before you push it down to the switches.
One other question, can you manipulate that configuration before it's pushed?
Yes, you can. You can go in and you will be able to edit the configuration. Say, for example, we are talking about changing the VRFs. Instead of having it at guest, you want to or IoT, or you want to add a new VRF, anything of that sort, you will be able to do that. So edit functions will be available in order to manipulate. After you do the construct, you can edit and make changes to it. Good question.
I've got a follow-up to Jason's as well. As you're pushing that configuration from Mist, what protocols are in play to get that information from the cloud down to your infrastructure gear?
So
Sure.
For all switches, anything when we are talking about netconf over SSH is what we use for communication between the switch and the cloud. Netconf over SSH on TCP port 2200 is what we use. So you have to make sure that that port is open outbound from the switch to, so we use netconf over SSH for all configuration pushes, let it be any switches and whatever your intent is. It could be a simple access layer switch to the full campus fabric. That's what we use.
So it's technically the switch initiating the conversation. So the cloud just has to be able to reply to that. I don't have to actually open up connectivity for the cloud to initiate. Is that correct?
That's correct. We formed the outbound SSH connection from the switch to the cloud, And then once you start defining your intent in the cloud and you have this EVPN configuration ready to go, or it may be a simple access switch configuration, we push that configuration from the cloud inside that inside that SSH configuration, which is going to your switch. So it's initiated from the switch, but the cloud has the control over, because we want one source of truth. So you don't want to go and do any configurations on the switches locally. You want the cloud to push down the configurations from there to the switches. Does that answer your question?
Yes. The only other follow-up I have is you said that you don't want people to have to go into the CLI. You're not locking it down to where they cannot, are you? You're just showing that you want.
No.
Okay.
Absolutely no. Customers will have full access to the CLI. They will be going in and looking into all the commands which are pushing, or they will be able to execute the show commands, etc. So we are not locking that out. Absolutely. But what we recommend is, do not make any configuration changes directly on the box via SSH or something like that, because the cloud is the single source of truth. We want the cloud to be the single source of truth. So as a result, next time we push that configuration from the cloud to the switch, we are going to override that configuration. So if you have some configurations to be done on the switch directly, go to the cloud. From the cloud, you have the section for CLI if the feature is not there, but we want to keep that to minimum, but do everything from the cloud so that you have one master controlling the networks. We have tried having multiple masters to a switch. It doesn't work. The industry has failed on that, where you go make changes from multiple places. It doesn't work. A lot of people have tried over a period of time. One master, which is the cloud. Answers your question?
Yes, thank you.
Okay, great. So say that, Abhi, you want to take it away? Are we going to jump into the demos at this point?
Yeah, this is going to be the IP class demo. There's a simple deployment that we're going to showcase currently as a part of this demonstration. Again, we spoke about the intent being the core of all of this, right? Even in the 4 steps that Sujit described, we said, you let us know what you'd like to do. You've chosen IP class in this case. You let us know what your roles of each devices are. In this case, the 4300 MP and the 4400, they are residing 4300 MP in the access layer. There's a distribution layer in between, EX switches, and you also have 4400 sitting as cores. You're just defining the roles in there. You've described what your networks look like. And as long as you let us know what your physical connections are, this would be the intent for us to tell. The previous slide, we spoke about BGP underlay, overlay configurations, VXLAN, where exactly the virtual gateway sits. All of that is for us to take care of instead, where you can focus on the user experience. And that's exactly what this demo will focus on. Awesome. So here we have a few switches that are listed, exactly the 4 switches. In fact, we spoke about EX4400 in distribution, 2 devices in access, and 2 devices in core. You name your topology. You said your intent is to go change the topology to be campus fabric. You name your topology. There are a few settings you can still control, the BGP overlay and underlay, and especially if you're working in a environment where you have already configured BGP. So we will allow you to control your AS numbers. Next step is for you to select devices. You're just selecting, you've identified core distribution and access, simply put in place. Now you go about selecting those devices. Once you select them, you hit continue. The next piece for us from here is going to be what your intent was. Tell us what exactly those networks were. If you've already defined all of your VLANs as a part of a Mist deployment and you're now migrating, we allow you to import all the existing VLANs already. So in this case, we just said, let's go ahead and import all of our VLANs from an already present template. If not, you could go about adding them as well. Once you define your template, you would want, since it's an IP class network, you will want all of these networks to be also defined at your edge, because it's edge routed, for them to get the IP addresses. Then you go about segmenting your network. We said we want to have a separate camera network, we want to have a separate corporate network, and we want to have a separate VRF for your IoT network as well. The VRF configurations are as simple as what you're seeing here. Go about selecting the VLANs and put them on the VRFs of your choice, and you can have more than one VLANs in there as well. Next comes the physical connections themselves. We will look to improve this as we go along. Automatically identifying from LLDP maybe, but for now, we allow you to select exactly the device, how the device is connected. How do you connect from your distribution to the core? You click the links. How do you connect from your access to your distribution? You enable those particular links as well. Once these physical links are present, one of our intents is for us, for you to actually get this, especially if you're doing this greenfield, pass this exact simulation, exact connectivity in a form of a CSC to your installers as well. Now you see here your configuration that we just built as a part of the IP clause is ready to go. You go about and hit apply changes, and that is pretty much all you would do in terms of deploying a full-blown IP clause fabric with end-to-end EVPN-VXLAN. And that is the intent that we've always been wanting, to bring in the simplicity into the network.
Quick question on that.
Sure.
Yeah. So one of the great challenges, running larger organizations is naming conventions. I know it's not a big deal, but the reality is that you just went through and named them VRF dash. Probably half a dozen of us would have named it something else, maybe the functional unit first, et cetera. Is there a way for you guys to actually set a naming standard that works sort of across the board to make it consistent, regardless of what fabric you're building at what data center site location, to keep things consistent? How does that work out? How are you guys actually pushing that sort of, consistent naming conventions and consistent numbering conventions that a team might have from an architecture level down into the actual, configuration platform side?
No, that's a good question. So in our switching templates, even with the traditional deployments, we encourage everybody to use one common template. We start with for example, the VLANs themselves. You just define the VLANs once across your entire network, and we will be able to percolate VLANs only for switches, which you need VLANs for. Maintaining consistency across all switches, and this template can be applicable across your entire organization, irrespective of the role of switches, be it distribution, be it access, or even be it core switches if you're doing VLANs there. The consistency is enforced in two spaces. One, we encourage you to just use one template. So you're just creating VLANs once. You're not repeating the same thing over and over again across thousands of switches. Two, the aspect of using templates and percolating to all switches at one shot gives you consistency, both in terms of it also helps a lot of our customers they've also built the discipline of having standardized port configurations as well, using this format. Now, bringing the same school of thought to what we just spoke about, the VRFs. Again, the templates here will be exactly the same. You could repeat the same template. You could download this as a JSON and re-import it back again in site 2, site 3, site 4, over and over again. That way, you're not redoing and repeating everything again. Rather, you're enforcing consistency in the sense that template brings that sort of discipline in there. I don't know if that exactly answered the question, but
I think some of the challenges for bigger organizations is you have multiple teams that are working in different subject areas. So if you're a VMware using, NSX, and you've got a whole set of constructs that you're using for route controls, security controls, and other things, you want to delegate that access for those components. And the only thing the switching platform is really doing is providing some sort of layer 3 pass-through, right, to get to the appropriate area. But you might have other areas of your data center with physical infrastructure, and the network team is having to map out everything that's required for that. Are you maintaining two sets of templates at that point? Or are you having a different way to enforce policy that makes more sense? And I sort of know some of the answers, but I'm just trying to open it up to give you guys a chance to talk about it.
No, yeah. I mean, in terms of configurations, again, we can definitely do labels for us to exactly inherit exact same labels. We've also provided an ability to import your templates directly even into the EVPN framework. But we want to be able to, we can further, see how we can. So there's multiple roles that are provided as well as network administrators. You can inherit the same templates across multiple teams as well. That is an option that is provided in the site construct. So if multiple teams are managing multiple sites differently, but still you can inherit the same template. We can also go dwell deeper in the functions of labels as well to enforce the same thing too.
One more question.
Sure.
Are you positioning this entirely for greenfield deployments, or is there a plan for landing and expanding into an existing campus network?
That's a really good question. So the architectures that Sujit positioned, I think the multi-homing will be a great foray for somebody coming into the campus networks. The volume runner switches are all your access switches. If you want to come into the world of Fabric, multi-homing is a great entry point because which is exactly the demo that we are going into next. The collapsed core are the two devices wherein you will start running EVPN and VXLAN. Your access switches will run exactly the same way they've always traditionally been running. There is no involvement of Fabric or VXLAN down to the access. You're just doing lags. So we will definitely enable migration of traditional architectures into multi-homing, and then eventually, higher levels of architectures too. But it's not just for greenfield. We can take over and do brownfield deployments too.
So does that mean if I'm doing that multi-homing design and I've got non-Juniper switches in that access layer that can speak VXLAN, I can still use this?
You don't even have to speak VXLAN. All you have to do
because
is
they've got the VTEPs.
All you have to do is the lag LACP,
okay.
and that's all you have to do. Yes, we'd like for you to not use other switches, but if you're still using other switches, yeah, we can still do it.
Okay, great.
Okay, perfect. So before we jump into the EVPN multi-homing demo out of it, what I have done at the back end is enable a couple of switches, and we want to do some live demo for those. So you can see those switches booting up over here, a couple of them. I will go to the bottom of it, and these are the switches booting up. While we show you the demo, these switches are booting up to see if we can do the full provisioning from the cloud.
What we are trying to do is actually deploy a multi-homing Fabric without you having to touch any of these devices. All of them through ZTP. Sujit just started these devices 9:26 a.m. And we're gonna deploy this Fabric, and Sujit, it's the same constructs that we did, right? We'll go through the topology of your choice, the networks that you want to define, and the devices and their roles. So let's go ahead and Sujit.
So yeah, so you have the devices over here configuring EVPN multi-homing, single site, enter the similar overlay, underlay. We enable now the collapsed core switches. We have two 4400s and one 2300 switch, which is acting as a access layer switch. And while we are doing this, we are now adding those networks. In this case, we have employee network mapped to VLAN 101, guest 102, and also at the same time, IoT with VLAN 103. Then you can enable DHCP or static. Most probably it will be DHCP, creating those three swim lanes for VRFs for employee, VRF for guest, and VRF for IoT. Then comes the part in case of core access is where we are talking about configuring those ESI lag information. This is the configuration which you push onto the switches, on the core switches, so that you can enable ESI lag, and which is connecting back to your access layer switches. So as you asked about, these access layer switches are using simple lag LSCP in order to communicate. So all the configurations are there on the collapsed core itself.
Sujit, 1 second on the previous one. So the core concept again, to Drew's point about can we enable outside of it as well. That is the only configuration that is required from a perspective of a access switch talking to anything in the collapse core. You have LACP, you set up your MTUs appropriately, and then you allow the networks of your choice using the trunk link. It's a traditional trunk link. It's instead of going to the same switch, it's just going to two switches, but the Ethernet segment identifier, from the perspective of the core switches themselves, they will identify, they know that these packets are coming from the exact same access switch because of the ESI technology, and we will be able to forward packets. And again, that's again why there is no spanning tree involved in this process, and one of the big pushes as to why we would want to move there. Go ahead, Sujit.
Absolutely. Thanks, Abhi, for jumping in over there. So now, once we have defined the networks or the three swim lanes, we enabled ESI lag to go down and connect to your access layer switches. Now let's walk through the physical connectivity on it. So you have the connection to your core. So this is the two connections between the EVPN switches. Now you're connecting the access to your access layer. Similarly, on the second switch, we perform the same operations, configuring those two ports and the link down. And then finally, we have the ESI lag configuration that is from the access switch, which is dual home to the two switches. That's what we are showing over here. Now we apply that intent, wait for a few minutes for all of these configurations to get pushed down. And in this setup of mine, I have a couple of switches, which I showed you in the beginning. It received all the configurations. The network is built. I have an access point which is connected. I have some clients which are connected. That could be Wi-Fi clients or could be wired clients. You can see now I have some LED devices connected, which is right beside me over here. And you can go in and look into the switch insights as well as the full configuration, which has been pushed to those switches. And we will show you all of this in the live network over here in a few seconds. So that's a quick look at how you do the deployment. You can see all the ports are changing. We are applying different types of profiles onto the port as we are going through dynamic port segmentation. And if you look at the back end, you can see the BGP is up, as well as the EVPN database up, and the EVPN database is built up. So that is one of the recorded ones I have, but I will share my screen and try to see what is going on with my live setup, moment of truth. So now we have two of the switches which are booted up. So here we have two switches over here. I'm going to log into them. This is my first.
So a couple of things that we can probably go into the dashboard, Sujit, and then we'll probably look at a few things in there.
Sure. 1 second, let me just type in the password and keep it ready. Sure. And so here is the dashboard.
Awesome. So we spoke about two things. At 9:26, we started booting off switches on Sujit's desk. Let's log into each of these switches. The switch insights are exactly where you would want to look at all pieces of what exactly happened. If you take a look at 9:30 at September 14th, that's the event where the switch came in out of in a scenario where it came just out of the box and reached the Mist Cloud, and it got its configuration. You see the configuration was pushed at 9:31. So it took about 4 minutes in total to finish ZTP as well as get the configurations that it required. And these are the core switches. You can see some of the BGP state changes coming through as well, but it also completed ZTP at around the 9:28 mark. So these switches obviously boot at a rapid pace. The 4400s are phenomenal in the sense with how quickly they boot up. But ZTP as well was completed, and as you can see, BGP state neighborship have also come up with its peer. From the access device perspective, we have a few things to showcase here too. If you go into the switch insights again, there are a couple of things that happen. As a part of the switch coming up, we can see there's a construct of dynamic port profiles. So we described an IoT port. There is an IoT lighting that is sitting there. We didn't have to go configure any of these ports automatically, but we said, here are the rules, and here is how we will assign all of these devices automatically to your network. That means an AP comes up on an access port, we give it the access port profile, as in it's a trunk port with 5 user VLANs. An IoT port, which is the Igor LED lighting that Sujit put in, it comes up, we provide it with the IoT segment. And then there's also the camera that comes in, and you'll see that there's dynamic port profile assignment done automatically for the camera as well. If you go back to the switches view on the 2300, Sujit, you will see the front panel showcasing exactly these things. The AP on port 10, port 11, the camera on port 10, and the LED light on port 6, listed with the host names and their corresponding profiles. The profile listed there is IoT. What we just did was we showcased to you a small campus that can be deployed without touching your access switches, without touching your collapse core devices, a console cable-less deployment of your entire network. Your APs are ready to go, your LED lights are ready to go. They've already gotten their VLANs and they're up and running. You can also see from the CLI, we don't lock down CLI. We'll encourage you to definitely look, troubleshoot, and do any of the show commands from the CLI perspective. All of them are up and running. Your EVPN database is now populated with the right IP to MAC binding. Your BGP summary indicates that your peering between the two devices are up. But as administrators, we want you to trust us to deploy this in its true sense of zero-touch provisioning of campus. That's the demo that we wanted to showcase. Glad it worked out.